Hello, welcome. Today let's try to solve another LeetCode problem. 2604 minimum time to eat all greens. So let me explain the problem first and then try to solve it in the code editor. Now let me explain this problem. So basically we are giving an array hands. So inside there are numbers. So these numbers means the position of the hands. So for example, the position of the hands is at 3, 6, and 7. Yeah. And we are also giving an array of greens. So this greens just means the position of the greens. So for example, the position of the greens may be like here 2, 4, 7, and 9. Yeah, and those arrays are not sorted. So in this example, it is just sorted, but in the real testing cases, so these hands and grids are not sorted in increasing order because it is not mentioned in the description. Yeah. So we are going to return. Let me check the return. The minimum time to eat all grids if the hands act optimally. Yeah. So this is an optimization problem, and it is also a minimum problem. If we say the word like minimum or maximum, normally it will be the binary search to get an answer. So I call it binary search plus get answer. So we need to return the minimum time to eat all grids if the hands act optimally. So for example, if the hands want to eat all those grids, what is the minimum time? So for example, for the first hand here, it is in the position 3. It can eat this grid, the first grid. So it takes one time. Because for when it moves at its position, moves to one step, it takes one time. But while the hands eating the grid, it didn't consume any time. So it means when the hands from here eat this one grid at position 2, it will take one time. Now, can the hands eat this grid? Yes, because if we are using two steps, so the hands can eat this grid from position 2 to 4. So it can eat the second grid. So I call it another grid. So currently, uh, but it is not working like that. If this hands moves like one step from 3 to 2 and then 2 to 4, it consumed 3 steps, but our answer is 2. So this means if our guess is 2 steps, so for the first hands, what C or what 8, what it can only eat it can only eat the first grid at position 2. Because it has already consumed one step. It cannot move to 2 steps to 4. It means this one can be finished by this hand. And then we are going to check the second hand. If the second hand at position 6, it is here. So this one can finish the second grid at position 4 because 6 minus 4 it is 2. So it means this can also be finished by the second hand. But can this hand eat at position 7? No, because this hand has already consumed 2 steps. So now we are going to check the last hands at position 7. So at 7, it didn't need to take any time to consume this position at 7, and then it will take another 2 seconds maybe. Eat the green at position 9. So for the last hand, for the last hand at this position 7, so this hand can eat 2 grids at position 7 and position 9. It also consumed 2 steps. So this means, if the answer is 2, the hands can finish eating all the greens, and this is also the minimum. If it is only one step, as we know, it cannot, because at position 3 we can finish this one. At position 6, maybe it can finish this 7. At position 7, it can also finish 7. But for that 4 and 9, it cannot finish when the steps Yeah, when the time is only 1. So it means the minimum time must be 2. Yeah, but exactly how should we solve this problem? Yeah, this is just for analyzing. It means that analyzing for this example, it can finish eating all the grains. But for the real situations, it is like this. So like we are having hands at the prison here, here, or here. Yeah, yeah. It is a bigger. So for the bigger one, this is the hands. Yeah. Now I'm going to draw. So this is in one line. So I will make it one line. So we have 3 hands, for example. Yeah. And we are also having some hands. So the hands will be placed like this. Yeah. So we'll make it a 1D array. Yeah, it is not 2D, just for simplicity. But in real cases, maybe the hands is here, the grains may be at the like this around it. But for our problem, it is only can be this prison. And now let me make a drawing of the grains. So for the grains, if this hands is here, so the grains can be at some point here. Yeah, or it can be some point here. So for the second hands, maybe the grains will be at some point here, or at some point here. And then at these areas, maybe there's also some grains. Yeah. So as you can see the drawing, maybe the first hands can consume these areas, like from the left to the right, these areas. For the second hands, for example, it can consume from this area to this area. And for the last hands, the third hands can consume from this area to this area. Yeah. So this means we can use greedy to check if the hands can consume all the grains. So how should we use greedy? We should prepare a left border and a right border for the positions of the grains. So if the positions at the left side is here, at the right side is here, and inside there are many grains, it doesn't matter. But this is our hands. If our hands is inside or at the left border or at the right border, can consume all those grains. It means this hand's job is finished. This hand can finish all these areas. But exactly how this hand will eat these grains. So there are two methods. So one method is this hand will go to the left to finish the left areas, and then they will finish from the left to the right areas. So it means they will go the distance like from this one plus this one. Yeah, the first one plus the second one. There's also another case. So this hand is here. So they will first finish eating from the right side, and then they will just go back to the left side to finish eating all these areas. Yeah, so this is the first method, and this is the second method. Yeah, and similarly for the other hands, it's the same. Yeah, they will go to the left and to right. So they will go to the right and then go to the left. But what they need to do is just finish eating the grains near to her or next to her, all these areas. For this one, also the same. Yeah. So we need to calculate the minimum of the distance. So this distance is 1 plus 2. So maybe here this distance is 3. We call it this distance is 3, and this is still 2. Yeah. So it is the minimum of 1 plus 2. So this is not a number. This is let me make it a character. Yeah. So this is A, this is B, and this is let me make it C, and this is also B. Yeah. So it will be the minimum of A plus B with C plus B. Yeah. Now let's check what is B and what is A and C. Yeah. So inside, so this will be the minimum of those values. So if the hands can finish all those areas, the minimum of A plus B with C plus B, it means in these areas the hands can finish eating. Yeah. And we are also going to guess this number 2. So if we are guessing with a number 2, so how should we check? if this minimum of these values is less than and equal to the threshold, if it is a 2 or the threshold, let me give a T8, yeah, as the threshold. If it is less than and equal to the threshold, it means this hen can finish eating all these areas. But what exactly is A and B? So for A, yeah, and for B. So if we give a minimum value, I use it as left, and at the right areas, I will use R as right. Yeah, so B should equal to R minus L. Yeah, so B should equal to R minus L. And what is A? So A should equal to the position of the hands. So position of the hands is hands I. Yeah, is hands I. This is the hands position. So the minus A. Yeah, hands I minus A is this A. Minus L. Yeah, so hands I minus L should equal to this A. Yeah, and here this C should equal to R minus hence I. Yeah. So this is a mathematical problem. Actually, we need to calculate all these positions. Yeah, what you need to understand and is this is a grading method. We need to sort the hands and grids because it is in a line. We need to sort it and then use grading method to check if the hands can finish eating all those grids with a threshold of 2 or other numbers. Yeah. And for calculating this distance like A, B, C, and B, we can use R minus L is equal to B. And here this A equal to the position of hands I minus minus L, and this is R minus hands I. Yeah, we can calculate all those positions. Yeah, now let me go back to the code editor to finish the coding. So basically, this is a template problem. We are using binary search to get an answer. So it will be L and R with my result. Let me prepare the check function first. So the check function inside will be a threshold as the template of binary search with a guess answer. Yeah, and LR and the result should be equal to L. Let me check L should be the minimum position. Yeah, should be started from 0, and the R should be 2 times 10 to the power of 9. Yeah, this is difficult to calculate, so I will not use the array like hands and grids to calculate because it's really difficult. So I will just use the maximum number, 10 to the power of 9, and the hands position maybe at 0, but the hands will go to left and go to right, so I will need to use 2 times 10 to the power of 9. Yeah, let me make a drawing here. Yeah, so here, this is all the grids area. Yeah, if the grids is in this line, and this is 0, and this is 10 to the power of 9. Yeah, if this is 10 to the power of 9, and if the hands is at this position, so the hands will go left and go right, or if the hands is at this position, so the hands will go left and right. Yeah, or maybe, yeah, go left and right. Maybe the hands is here, so will go here and here, but basically I will use 2 times 10 to the power of 9 as my upper boundary for this R. Later on, I will try if I don't need to use 2, but let's put it 2 times 10 to the power of 9, and the result would be 0. Now I just use the template code to check my answer. Yeah, so the M should equal to L plus R minus L divided by 2. So if check with this M, and I will give a result as M, and I will update the, yeah, this means I guessed a number. This number is right, so but it is too big. So what about a smaller number? Yeah, else I will use else would equal to m plus 1. Yeah. So this means if the number is too small, so what about try a bigger number? Yeah. Now the difficult part is about this check function. But before the check function, we can do some preparations. Yeah. Basically, this hands and this greens should be sorted while we are using the greedy method to check. Yeah. After sorting the two arrays, I will initialize the two pointers started from 0. Yeah, it is just two indexes for the hands and greens. So I index is for the hands and J index is for the greens. Yeah. Now I'm going to check. So while I less than the hands. Yeah, I'm going to check inside the hands. Yeah, for example, I'm going to check. For example, this is my hand. Can this hand finish eating in these areas? So I'm going to check the first one and then the second one. Yeah. So this is the first hands. Yeah, now I'm going to prepare two borders, right and left, should equal to the hands I with the hands I. I will initialize as the position of the hands. So while I will use this hands position, so from beginning I will give a boundary of left and right as my hands. After that, the boundary will be updated. For example, so if the hands is at this position, so I will give a left and right, both at this area. Now, after that, I will check the greens. If there are greens in these areas, so my left and right will be updated as here and here. Yeah. Yeah. Now, I updated the left and right boundary. I'm going to check the greens. So while J less than the line of greens. Yeah, so now I'm going to check the greens, but yeah, I'm going to update with the left and right. So the left and right should be updated to the mean, because at the left side it will always be minimum of left with my greens J. Yeah, because the greens position will be updated from the left to the right, like from here. If the hands is here, if the green is come here and here, so the left and right will be updated like that. Now I'm going to update the greens as well. So the greens will be the maximum with right and greens J. Yeah. Now I'm going to use a formula. So if minimum, yeah. So this formula is basically here. Yeah, there are two ways: go to left and go to right, or go to right and go to left. Yeah. So it will be. Let me think about it. The formula. So it will be the position. Yeah. So my position is yeah, hands. The hands I minus a left. It means the hands will go to the left, and plus right minus left. Yeah, and there's another way. So the right will minus hands I. So this means the hands will go to the right, and then from the right go to the left. So also plus the right minus left. Yeah, let me make it one line. Yeah, so if this is minimum of them is less than and equal to the threshold, so I can update the J pointer by 1. Otherwise, if it is not, I will break the inner while loop immediately. Yeah, I will make a break and check for the next hands. So this means, yeah, if this hands finish its job, so for the next hands, it will finish this area. For the last hands, it will finish this area. If the last hands cannot finish this area, maybe there's some greens left, so I gonna return false. Otherwise, I gonna return true. Now I just need to update the iPorter because it's a while loop. And finally, I'm going to check if j equal to the length of Greens. Yeah. So this is basically the entire code. Now let me give a final result. So as the result, yeah, let me check if there's something wrong with the code. So basically, I prepare 2 pointers for the hands and for the Greens. So this is the right and left, and after that I go inside, update the right and left, and then I'm going to use this formula to check and update the Greens by 1. Yeah, finally update the hands by 1, and finally I'm going to check if it is yeah, true or false. Now let me run it to check if it is okay. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases. Now let me try to submit again. Yeah. Yeah, I think it passed. So it's just because the time is the same. You may not say this value is updated, but actually it passed. Now let's try to change this value. Yeah, because we need to, maybe sometimes we need to analyze this iPorter, the maximum value. Let's check the maximum value. Yeah, this maximum value is 10 to the power of 9. Let me check. So yeah, for example, let me delete these areas. Yeah. So for example, if yeah, I will use a blue pen. So for example, this is the boundary from the left to the right, and inside there are always be grids, and this is 0, and this is 10 to the power of 9. Yeah, and in this area, basically, the hands will try to eat all the greens. So what about the hands is here? So they will go from this side and then go to the right side. Yeah, it is the distance is this one plus this one. Or it will be here. It can directly go to this area to eat all the greens. Yeah. Or this hands, yeah, because this is the minimum. Or the hands will be in the middle. So it will eat from here and then go back. So it means it's not 2, it is 3 divided by 2. Now let's try to use the 3 divided by 2 to check if this is okay. Yeah, so this should be 3 divided 2 times 10 to the power of 9. Yeah. Now let me run it to check. I should use yeah, I should use yeah, I should use 15. Yeah, let me use 1.5 times 10 to the power of 9 to see if it is okay. This is yeah, I should not use yeah, but basically let me check. Yeah, so I will use this value 10 to the power of 9 plus 5 times 10 to the power of 8. I think this one should be okay. Yeah, now let me run it to check. Oh, this is not okay because this is a too big number. I made a typo. Yeah, I have to run again to check. Yeah, as you can see, this works. This is just means 10 to the power of 9 and plus half 10 to the power of 9 just to check if it works. I believe it works because this is the maximum distance. But normally we don't need to do this, I believe. Yeah, as you can see, it also passed. Yeah, but this is actually the entire code. Let me try to explain the time complexity. From here, it is a log r minus L. Yeah, basically this r minus l is 10 to the power of 9. Yeah, and from here we sorted the two arrays. So this is n log n. So let's check if the length of the hands or the greens is n. So this is n log n, and yeah, this n log n need to compare with this areas. This areas is log r minus l, and here basically we have two while loops. Yeah, but these two while loops is not n square. Yeah, this while loop is only m plus n. Yeah, because even here we have a while loop. Yeah, but inside this area, this j can be updated to a lot of values, even for 1i. Yeah, so I believe here. So yeah, let me check from here. Yeah, so we are going to check, for example, we are going to check these hands, and in these areas there will be a lot of greens. It will be finished. After that, we are not going to check this greens and this hands. And then we shift to the next hand, and we are going to check this greens. And for the third hand, we are going to check this greens. As we can check that. So this is basically the time of m plus n. It is not m times n. It is just m plus n. Yeah, because we didn't repeat all those calculations. When we finish these areas, what is the time? So this is one half, maybe plus n1 greens. And for this one, for the second one, there's another half, one half plus n2 greens. Yeah. Now we are going to plus all these areas, so it means it is m halves, and then n1 plus n2 and plus all those n's, it will be n. So this is why this areas, the time complexity is m plus n times log r minus l. Yeah, and also with the minimum of this number and minimum of n log n. Yeah. So finally, if this m equals to n, it is n log. Yeah. So the time complexity should be n log r minus l. Yeah. So this is the final time complexity. Let me put it here. It should be, yeah, n log r minus l. Yeah, because this is the biggest value it can be. Yeah, so n is the length of the greens. So this is why it can pass. Otherwise, it cannot pass